Hello everyone, how to solve this problem for the values of x if we have x minus 1 over 2 whole square is equals to 64, and we solve this problem for the values of x. So here first we find all the roots of this equation, and at the last we will verify that which of the roots are solution of this equation and which of the roots are extraneous roots. And at the last I can explain the term extraneous root, so please watch this video at the end. I hope so you like this video. And also we will solve this problem for two methods. I hope so you like both of these methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now here we move towards our first method, and in the first method first we need to take a square root on both of the sides of this equation, and when we will take square root on both of the sides, it will be written as in this form: x minus 1 over 2 whole square and its square root is equals to square root of 64. And now further you see here this 2 and the square root are gone, and we will get here x minus 1 over 2 is equals to, here we know that square root of 64 is equals to 8. Also you know about that when we will take square root on both of the sides, then we write here plus minus sign any one of the sides, so we write plus minus sign into the right hand side. And now further we move this 2 to the right hand side. You see here it is divided by, here when we move it into the right hand side it is multiplied by plus minus 8. So when we multiply this 2 with this 8, it will be written as plus minus 16. And now here further in the next step we need to divide this equation into the two cases. The first case is we write here the positive right hand side, and the second case is we write the negative right hand side. Okay, so from here we easily get the value of x is equals to, this is 16, this is minus 1. When we move this minus 1 to the right hand side, it will becomes plus 1. In the same pattern, here we move this minus 1 to the right hand side and it will becomes also plus 1. And further you see here in the next step, here we get the value of x is equals to 17, and from here we get the value of x is equals to minus 15. So from first method we get the two roots of the given equation, and further here we will check that is both of these roots are solution or extraneous roots. So for verification of the roots, we need to copy down given question statement. Here it is x minus 1 over 2 whole square equals to 64. And now here we need to put above both values of x into the left hand side of this equation. So here we put x is equals to 17, and here we substitute x is equals to minus 15. So when you put this value here, it will become 17 minus 1 over 2 whole square is equals to 64, and from here we have minus 15 minus 1 over 2 whole square is equals to 64. And now further in the next step we need more simplification, and we get 17 minus 1 becomes 16 over 2 whole square is equals to 64, and from here we get minus 16 over 2 whole square is equals to 64. So these are cancelled out by each other, and we get 2 8 the 16. We get here 8 square equals to 64, and here we get 2 8 the 16. We get minus 8 square equals to 64. So this will becomes 64 equals to 64. So this shows that the value of x is equals to 17 is satisfied our given question statement. In the same pattern, we have minus 8 square is also equals to minus 64 equals to 64. So the second root of x is also satisfied our given question statement. So both of these roots are satisfied our given question statement. And further in the next step we again solve this problem for second method. So for this we need to copy down given question statement here, and the given question statement is x minus 1 over 2 whole square is equals to 64. This is our given question statement, and here we solve again this problem for second method. So in second method here, we just first break this square in the left hand side and we apply the square separately on numerator and denominator as well. So it will be written as x minus 1 whole square divided by 2 square is equals to 64. So here further we need to we move this 2 square to the right hand side and it will be written as x minus 1 whole square is equals to, here we write this 64 as 8 square and we move this 2 square in the left hand side. In the right hand side it will also becomes here 2 square. So further in the next step, so we need to combine the square of both of these terms and it will be written as x minus 1 whole square is equals to, when we combine these two squares it will becomes 8 times of 2 whole square. And further in the next step we have this is x minus 1 whole square is equals to, this is 8 times of 2 becomes 16 square. So further we move this 16 square into the left hand side and it will be written as x minus 1 whole square minus 16 square is equals to 0. And here we need to use the nice algebraic formula, you know about that. If we have a square minus b square is equals to a minus b times of a plus b. According to this rule we have, this is the base of this term is our a and the base of this term is our b. So here we just substitute the values of a and b into the below formula. So according to the below formula we write our above equation as, first we have a minus b, the value of a is x minus 1 minus the value of b is 16, and again a plus b, the value of a is x minus 1 plus the value of b is 16 is equals to 0. So here we have, this will becomes x minus 17 and this will becomes x plus 15 is equals to 0. So now we divide this into the two cases. The first case is we write x minus 17 is equals to 0. The second case is we write x plus 15 is equals to 0. From here we easily get the value of x is equals to 17. From here we easily get the value of x is equals to minus 15. So again into the second method we get the same value of x which we get here from first method, and also we verify these two values into the first method. So these are the two solutions of the given equation. This is the final answer and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.